join, please switch on your camera. Give me a moment. I'm still setting up my Windows. Alright. Let's see. Okay. Can everybody see my? Can everyone see my presentation?
Yes.
Okay. Alright. So basically, we have 5 basic pain potential. Okay. The other name given to this is basic pain flows or elementary flows. All of them basically meant the same. Okay. So we have 5. Number 1 is uniform flow, source, sink, doublet. Okay. The last one is irrotational vortex. So we start with a uniform flow. Okay. So basically, uniform flow is just a flow from left to right or right to left. Just a straight flow. Okay. If you see here is we have the sine. Okay. Normally, what we do is the one at the axis, right? You put that as a psi 0, okay? Because it's positioned at the x-axis. Okay. And then you have psi 1, psi 2, and psi 3. So, and then you have also negative. Okay, negative psi 1, psi 2, and psi 3. So based on the axis. Similarly, with phi, you're going to have phi1 and phi2, positive direction, and phi1 and phi2, negative direction to the other side. So it's actually based on the axis. Okay, imagine if your axis is flipped. X is actually to the left. Okay, so your phi is going to be different. The one that we have to the left is going to be positive. The one to the right is going to be negative. Similar to y direction as well. Okay, alright. So let's see the equation. So we're going to use our equation previously. So you have u equals to del psi over del 1, right? Okay, our objective here is actually to find psi. Perhaps u is given, like our previous example. U is at a certain um, equation, u equal to 4x plus 2xy, for example, right? So our objective is to find psi. So what we're going to do is we're going to integrate both sides, right? So you're going to have the psi equals to u dy, right? So you integrate both sides. So you're gonna have psi equals to u y plus c. Um, c here is gonna what? Gonna ignore that, right? So what you have is psi equals to u. Okay. So as you can see, psi, right? Psi number one is actually replaced what? Based on this equation, it's actually based on the direction of y, the distance of y. For example, from here to here, perhaps 2 meters, example. So you're gonna have psi equals to u, whatever u, multiplied with the y direction. So this basically represents this psi. So how about psi number two? Perhaps now 4 meter, right? So you put 4 meter there, so you're gonna have psi number two. So yeah. So next, we need to find phi. So in order for us to find phi, we're gonna use u as well. So u equal to del phi over del x. Okay, so similar approach like what we did before. So you're gonna have phi equals to now set to x. U equals to ux. Okay, so again, let's see the effect of x towards phi. So phi number one and phi number two is governed by the x distance. So in order for you to determine phi one, meaning you're gonna have x1 and then x2. Right? So this is what it means by psi equals to uy and psi equals to ux. Any question? So you're gonna get the idea later. All equations that I'm gonna introduce to you is basically represent the position of psi at the distance. Okay, either due to theta, okay, r and all. Okay. So those general equation, when you put the values, basically it's gonna represent the position of the psi, the position of the phi. Okay. Right. So next, we go for polar coordinates. Um, so this is polar, right? So how we're gonna do this is basically we will relate x, y, and r. We're gonna use triangle. So this one should be y, and this is actually x. And this one is theta. This one is R. Okay. R direction, theta direction, Y and X. Okay. Give me the value of Y. Y equals to what? In terms of R. Anyone?
R sin theta.
Yes, good. R sine theta, right? So Y is actually R sine. So it starts with the sine, of course. Um, let me put this. I mean, sine theta opposite hypotenuse. So you have Y divided by R. Okay, so from there, you're going to get Y equals to R sine. Okay, how about X?
R cos
R cos theta.
theta.
Okay, so by knowing this, right? So obviously for psi in polar coordinates, just now is u equals to psi equals to uy, right? So meaning psi equals to ur sin theta. Now you're gonna have psi in polar coordinates, and then you have phi equals to ur cos, right? Okay, so the idea here will be similar. Okay, so if you want to determine in polar coordinates psi number 1, psi number 2, you need to put in the radius, the distance of the radius, and then the angle. So that's how we determine psi 1, psi 2. Perhaps if it goes to psi number 3, um, the angle will be increased, right? Angle will be increased. And perhaps the R will be the same, but angle will be increased. So that's how we determine psi 1, psi 2. So similar recipe. Okay, any question? Okay, the characteristic of uniform flow is, you can read that. Actually, streamlines that are all straight and parallel. in the methods of velocity is constant, doesn't change, of course, because we assume steady flow, right? It does not change with time. Even we have two phases, for example, velocity at this position is 2 meter per second, velocity at that position is 4 meter per second. But it does not change with time. It maintains 2 and 4 at any given time. Um, at the period that you want to study, right? So it doesn't change. 2, 4, 2, 4. So that's what it meant by steady flow. All right. Any question? Uniform flow? Okay. Now we go to source flow. Okay. I believe I showed to you a video, the actual phenomena that represent source flow. You have a water droplets falling on top of a water surface, and you will have a ripple, right? So the direction of ripple, where it moves, is actually the streamlines. So as you can see here, is actually source flow. So at the moment, ignore the simple. Let's focus on the source flow. Yes. Okay. So the ripple is something like this. So this is P number 1. This one is P number Y1 and 2 because of P1, the one that generated first, and P2, the one that generated later, based on the direction. Okay. Now take a look. Based on the videos, right? The area is expand. It become larger. So there is a change of area, right? Okay, there is a change of area. So let's do this. So I draw a circle to represent the expansion of the ripple. Now, the ripple is actually the expansion of those phenomena. Okay, they expand. So this is area. Okay. So do you understand? Change of area. So represent by dA. Okay. So before I proceed with explanation of dA, so let me ask you: is this Cartesian or polar coordinates problem? Polar, right? Why? Yeah. I mean, we have R and theta. Okay. I mean what? The shape of it. Okay, the shape of the source with an angle, and the direction is radius. Okay. So first, so we are not gonna use U and U, right? Because our component number state is in U direction. Okay. So we are not gonna use U and V, for example. So here we're gonna use VR and V data. Okay, but the thing is, one of them is not equals to 0. So which one is equals to 0? Which one is not equals to 0? This flow, this blue color line, is it VR or V theta? One Yusuf.
Yes, sir.
Wanna try?
VR, sir.
VR.
Yeah.
How about V theta?
What?
How about V theta?
V theta, I think the circle.
So for source flow, is there any V theta?
Yeah, yeah.
Take a look at the direction of flow. Okay. One Yusuf answer is there will be a VR. Okay. VR is not equals to 0. Right? It's correct. Because the direction of flow is VR. So VR is not equals to 0. V theta equals to 0 because there is no V theta, right? Our problem is this way. There's no rotation to the source plane. So that's why V theta equals to. Any problem on this? Am I clear? You all understand? Okay. All right. So next we analyze dA. So after we found our velocity, we analyze dA. Okay, dA. Can you give me the equation for circumference? If area is pi r squared, how about circumference?
2 by R.
2 pi r, right? So this is actually 2 pi r. We want to find the change of area. So mean 2 pi r multiply with the length. So let's represent this one as a plate. So the length from here to here is actually 2 pi r. And the height is represented by L. So that's how we determine the change of. Okay, and the length based on the R, right? This is the R, so meaning this one is actually the change of R. So what you have is the A equals to 2 pi R dr. Dot A. So next, what we want is we're gonna use Q. So the general equation for Q is Q equals to AV. But since our problem is polar and we have a change of area, so we need VR. So Q equals to VR multiplied by dA. So we replace dA with 2 pi r dr. Okay. Our objective is to find VR. Okay. So since this is change of area, so our Q can be represented by small q. So VR is equals to Q divided by 2 pi r dot theta. Okay. VR is not equals to 0. So what is VR? VR equals to Q divided by 2 pi r dr. Okay. So the other thing is the R, we consider that as a change of R. Okay, so we can control how we analyze that one. So we assume this is actually too small. It's not gonna be 0. If 0, the whole equation is cancelled out or infinity. Right? If this one is 0, it's gonna become.
Sir,
Yep.
habis baru masuk je.
Right? Switch on your camera. Okay. So dr is too small. Should be there, but too small. And the value can be ignored, right? So in the end, what happened to your equation is Q divided by 2 pi. So that is VR. Any question on this? So what are the next steps? Just now for uniform flow, we determine psi and phi. So the same. So what we need to do is we need to find psi. So we're gonna use what VR, right? So we have our VR. So VR is equals to 1 over R del psi over del theta. Okay. So you're gonna put your Q divided by 2 pi R into this equation. So what you're gonna have is 1 over R del psi over del theta. So this one equals to Q divided by 2 pi. Okay. So from there, find me psi. Okay, I'll give you a minute to do that. So what is the value of psi? Anyone? Putri, Dania.
Yes, sir.
You want to try? What is the value of psi?
Q over 2 pi theta. Q theta over 2 pi.
Q theta over 2 pi. Okay. Yes, correct.
Plus C. Theta.
Let's see. Thank you. So you're gonna have Q divided by 2 pi theta plus C. But C again, just ignore it. Okay. So in the end, you have is psi equals to Q divided by 2 pi multiplied with theta. So similar approach, determine phi. So everyone do that now. So what is phi? Q divided by 2 pi Muhammad Naim.
Yes, sir. Q over 2 pi plus C.
Okay. Muhammad Nazri.
Yes, sir.
Your answer.
I don't get it, sir.
Your answer.
It's 9 hours.
My answer is R. We are plus C.
Okay. Thank you. Nazrin Shah.
Q over 2 pi, sir.
Q over 2 pi. Is that all?
Plus C.
Plus C. Okay. Alright. So let's do this together. VR is actually del phi, right? So del phi over del R. So means you're gonna have Q divided by 2 pi R. Then dr. So you're gonna integrate both sides, right? So what you're gonna have is del phi integrate become phi Q divided by 2 pi R. So you have it's actually 1 over R here that you need to integrate. What is the integration of 1 over R? Anyone remember?
Ln R.
Yeah, ln. So Q divided by 2 pi ln. No C, right? So this is your okay, done. So any question on source and sink? So what we determine actually, we already have our VR, we already have our V theta, which is VR is Q divided by 2 pi R, V theta is 0, and then you have psi, and then you have phi. If you notice, always when we try to solve elementary flows problem, or in this chapter, you always need to find VR, V theta. Doesn't matter whether one of them is 0 or not, based on cases. VR, V theta, psi, and phi. So take a look at this one. You have your U, right? And then you determine psi and phi for uniform flow. So any question? So next goes to sink. Let's go to sink. Alright. Sink flow is similar to source flow, but the different is the direction of flow, opposite direction. So meaning your phi is gonna be the same drawing, no different, but the direction of phi. So here is your phi1, and this one is your phi. Why? Because phi1 is you have phi1 first before they go to phi2. So this is same flow. So same approach, but what you're gonna have is for sync flow, the value is similar but negative. So for VR, negative Q divided by 2 pi R, sine negative, and also P also. So that's how it is for sync. Then, so we can use source flow and sync flow. Okay, next we go to irrotational vortex. So what kind of flow is this? Is basically you have a vortex and we assume counterclockwise as the positive direction. So if we have a clockwise problem, since we engineer assume negative counterclockwise as positive, so if it is clockwise, we can negative. That's it. That's all. So in general, we assume as a vortex counterclockwise as the positive. Okay. So again, you're gonna have VR and V theta because this is polar coordinates, right? So which one is zero? Which one is not zero?
VR 0.
No VR, correct? Yes, good. No VR. Our flow is only circulation. I don't want to say circulation because it means something else, right? It rotates. So V theta is not zero, so VR zero. Like what we did before, determine VR. So this one is V theta. So I just directly give you the value. So V theta is equals to kappa divided by 2 pi R. So that is V theta. Kappa is, from the previous lecture, is actually circulation. So it's actually the strength of vortex. Why the strength of vortex? Because V theta 2 pi R is only a constant. I mean, if you want to determine V theta 2, for example, this is V theta 1, V theta 2, V theta 3, R is only the distance. So if you want V theta 1, this is the distance. You all can see my cursor, right? Can you all see my cursor?
Boleh saya.
Well, yeah.
Nampak saya nampak.
Right. So for V theta 1, R, this is the distance of R. For V theta 2, this is the distance of R2. Okay. So the one that controls the magnitude of V theta is kappa, circulation. So what is kappa? Kappa is the rotation or line vortex that position at the origin. So some sort like something like that, right? So basically a position at the origin. So how to calculate kappa? Check back your previous lecture, zeta dA, right? Zeta dA. So how to get zeta? Refer back to your previous lecture. Del V over del X equals to 0. Alright. Kappa also, some books use K. So do not get surprised. It's actually C. So that is B theta. So for psi, again I'm just going to give you the equation. Negative K divided by 2 pi ln R. And then 2 pi. And then you have phi equals to negative K divided by 2 pi. So this is the equation that you need to remember. So always VR, V theta, psi, and done. So that is for irrotational vortex. So you have number 1, number 2, number 3, number 4. Okay, next we go to the last one, which is doublet. Okay, do not get confused. Doublet is actually superposition. What is superposition? Superposition is combination of elementary flows. Source and sink is elementary flows. But we put doublet here as an elementary flows as well because doublet is quite famous to be combined with other elementary flows to find other superposition. They use doublet, add another flows to make it something, another superposition. So that's why doublet, even though, like I mentioned just now, the combination of source and sink, but we consider that as an elementary flows, basically. Okay? Alright, now you have source and then you have sink. Can you draw me, draw for me the what happened to the combination of source and sink? Draw it for me now. Take out a piece of paper. So later I want to see how you draw. Combination of source and sink. So while you draw, I'll try to explain how they combine. Okay, source and sink, if it is far enough from each other, nothing would happen. But the thing is, if the source of strength, the strength of source and the strength of sink is perhaps quite strong, and the distance is not too far away, they will be attracted from source and sink. there will be attraction between each those source. So draw for me what happened to that attraction or the combination of these two. So are you all done? Alright. So I'll give you a minute, an extra 1 minute. Okay. Now pick up your paper, show it to the camera. I want to see. Okay, Najmi, wait. Najmi. Yeah, very good. You get the idea. Alright. Yang lain, yang lain. Everyone, pick up your paper, please. Let's see your ability to draw. Today you're gonna become artist. Afzatul, wait, Afzatul. Afzatul, yeah, correct. That one totally correct. This one is Irfan. Wait, Irfan. You get the idea. Also correct. Who else? Another one, perhaps. Somebody. Okay, alright. Nurul Huda, seems like you want to share. Show it to your camera. Pick it up. Yes, alright, correct. Also correct. Okay, I'm impressed since you got the idea. Yeah, almost all of you know how to draw this doublet. So what's gonna happen is this straight line, this different color, you're gonna what? Combine with this one. Because this one is source and this one is sink. Okay. And this one combine with this. So you're gonna have combination of these two elementary flows. Okay, if you draw it like this, it's okay, but maybe you want to make it more what in order for me to judge whether you understand or not. So this is sink, and this one is source. So meaning this arrow will be what? Attracted. Become like that. Attracted to this side. Same like this one. So this one is, instead of this, it's gonna type something like that. So just assume those red color is not there. Right? Yeah, that's how the update looks like. Okay. Alright, very good. So here I'm gonna give you the psi. So psi is equals to negative kappa sine theta divided by r. And then phi is actually equals to kappa cos theta divided by r. This is sine theta. So that is psi, and that is phi. Okay. So I'm gonna give you assignment for next week. Okay. What you need to do is you need to derive. Derive doublet. So your final answer will be this one, psi and phi. So you already have the answer, but what I want is actually how you derive this. How you derive the doublet. Okay, the idea would be, this is P. P meaning this is where you see the source and sink. Right? I mean the point of interest. Okay. So for the point of interest, the distance of source to the points of interest is R2, and distance of sink to the point of interest is R1. So you're going to have theta 1 and theta 2, and in between, the resulting of that is actually the theta and R. Okay. So you can use this figure, or perhaps you can use the other type of point of interest. Okay. But what we normally do is, we're going to have a certain point where we look the position of source and sink. So from there, we're going to derive psi and phi. Okay. Alright. Muhammad. Muhammad Izzuddin, is it? Muhammad Izzuddin.
Yes, sir.
When to submit?
Huh?
When you want to submit this assignment?
Terserah, sir.
Now I give you the opportunity to set the time.
Minggu depan, sir.
What day?
Thursday.
Right. So you submit next week Thursday. Okay, before this class. Okay. So we're not gonna take a break because we cannot do anything, right? Okay, we go for superposition. I briefly explained about superposition just now. So basically, superposition is, take a look here. Do not yet read the statement. So what you have is what? Phi 1 plus phi 2 become the resulting phi. So that's how we do with superposition. So what kind of flow is this? Anyone? Straight line, parallel. What kind of flow? What kind of elementary flow is this? From our previous 5 discussion just now, which one? Is it source? Or is it vortex?
Uniform.
This one is uniform flow. Plus, what is this?
Vortex.
Wrong. What is this? Vortex.
Source.
Concentric.
Source or sink.
Source or sink, right? Vortex is going to be this one, right? There's a rotation. That is vortex. So we add up, become this one. Okay, so in fact, this one is actually source flow, right? So what happened is these elementary flows, this uniform flow is gonna flow around the source flow. Okay, so that's why it becomes like this. It flows around. So this is where the location of the source. So the source at this arrow will be attracted to the back. divert to the back because of the direction of the uniform flow. Yeah, you're always gonna play around with fluid flows. Okay, so from this, you can see what is superposition. It's actually a process of adding two or more, so not only two, irrotational flow, meaning basic plane potential flow, okay, together to generate a third flow. So that's what it is, superposition. So not only two, it can be more, four also, five, and all. So perhaps if you have a vortex with what is a rotation and then it goes into a certain point. So that one is what? Combination of circulation, vortex just now, plus sink, because it goes into a certain point. The one that you, normal vortex that you see, right? Kat mana lah? In your bathroom or anywhere, in your sink, it rotates and it goes into a certain point. So it's combination of vortex plus sink. Because our vortex only simple as this. It knows it doesn't goes into a certain point. So when we combine with sink, now we get a vortex that you know. Okay. So that is superposition. Okay. The other thing is we try to give a name for it. Yeah. So this one is, we call this as a Rankine half body. So again, what you want to determine is the psi and the phi on, like what we did just now. So if you notice here, this is the source and this is the uniform flow. So what important on this superposition is how basically we want to determine the important features of the flow. For example, stagnation point. One of the feature of this flow. When you have a uniform flow from left to right and you have a source flow. So basically the fluid is actually opposite each other, right? So at a certain position, there will be what we call as a stagnation. You all see me, right? So there will be a stagnation where velocity at that point is actually zero. So V equals to zero. So that one become important features of that flow, right? So we try to give the distance from the source to that stagnation point is as B, right? So of course you have your theta and R. So theta is positive counterclockwise from the X and the R. So later, what you want actually, later perhaps you want to determine what are the psi at this distance. Okay. So by using the equation, put all the R and sine theta and all, you're gonna get the psi on this one. This one perhaps is gonna be zero because of psi this one zero, psi at the section point zero. Okay, this one need to analyze. Okay, so from theta here, so everything can be analyzed on this loop. Okay, that is Rankine half body, or sometimes we call that as a flow past a half body. Okay. So later I'm going to give you a video to show it to you how exactly this happened. Okay. Next is another one. This one is doublet. Just now. Okay. Next is this. You have a uniform flow with source and sink. What is source and sink just now? The one that you draw, we call that as what?
Doublet.
Doublet. See? So that's why doublet also become an elementary flows. Okay. So this is actually doublet, but it combines with uniform flow. So this combination produce what we call as a flow past a Rankine body, not half, Rankine body, full body. Just now is only half. But here you have source plus sink, total body of Rankine. And sometimes we call this as flow past a circular cylinder. Okay. Flow past a circular cylinder. Okay, once again you have stagnation point, but this time around you have two stagnation points, not only one. This is the position of the source, and this one is the position of the sink, right? So this is stagnation point 1 at the front, stagnation point 2 at the back. So you should know that this stagnation point is theta 0. This stagnation point is going to be theta 180 degree. Okay, that's how we classify this one. And the distance perhaps we still use by B, for example, here. Okay. So based on your problems. Okay. Doublet and uniform flow produce flow past a circular cylinder. Same like this one. Okay. So for superposition, wait. Everyone open up your Google Classroom now. Right. Yeah, I just post lecture on superposition. So the lecture on superposition will be a recorded video session. Okay. I believe I told you during our first class or perhaps second class. And even somebody asked me, where's the video? Because you want to record this one, right? But my method of teaching, I'm combine both. One face-to-face like this, so we can have a total discussion. Another one is recorded version of lecture. Okay. So some of the subchapter I already recorded for you. So you're gonna have both benefits of face-to-face and recorded. Okay. So you can watch that videos. So how many part? How many bahagian? Di situ?
3 part.
3 parts, right? So part A, part B, and part C. Okay. I'm not gonna use your free time. Okay. I'm gonna use the lecture, our class session as well. So part A, since we still have time because part A only 15 minutes, so you can watch it now. Okay. For part A. Part B and part C, you continue next week on Monday, right? Okay. Is it Monday? Monday or Tuesday?
Tuesday.
Tuesday. Okay, on Tuesday. For the first hour, you watch part B and part C. Okay. But if you want to watch it during your free time, up to you. But I fix a time for you to watch. So part A today, part B and part C next week on Tuesday 8 until 9. So after that, after you completed that, what you need to do? Take a look at the GC description.
Write in the comment section our full name.
Yes. Write in the comment section your full name. So now I know whether you've done your lecture session or not. And at 9 o'clock, we're gonna meet and we're gonna have Q&A session for those three videos. Okay, 15 minutes, 10 minutes, up to you. Even an hour also you can ask me. It's not a problem for me. But if you don't have any question or after you complete our Q&A session for those three videos, then we're gonna do our perhaps tutorial, any other thing, right? So that's how we do for our recorded video session lecture. Is it okay? All right. So you should expect perhaps chapter 4, another 2 sub-chapter is recorded, something like that. Okay. So my idea would be what? Would be, yeah, you can have not the whole session recorded video, not the whole session face to face. Right? So you can have, because every method have their own benefit side. So why not we do both? So any question? So we can end our session today while you watch your video. I'm gonna give your attendance now. Okay, so fill up your attendance. While waiting for it, if you have any question for the previous lecture before this lecture, you can ask. So only 22 students. This class should be 30 something, right? Another 2 students. Okay, so thank you. Um, we end our class with Tasbih Kifarah and Surah. Okay. Teruskan berpuasa. Hari ketiga. Belum raya lagi, jauh lagi. Assalamualaikum warahmatullahi wabarakatuh.
Salam. Thank you, sir.
Waalaikumsalam.
Salam.
Thank you, sir.
Waalaikumsalam. Thank you, sir.